you will call a transfer function. You will use something called a system identification to identify the transfer function. You try to identify any zeros and poles of the system. We call it as natural frequencies and resonant frequencies and anti-resonant frequencies of the function. I am trying to bring an equivalence because my PhD area is on signal processing, where I try to work on the area of system identification for structural algorithmic purpose. So, I think I belong to CSIR-STRUCTURAL Research Center. So basically, it is one of the 37 lab under Council of Scientific and Industrial Research. Basically, we have an expertise in structural engineering. We work in different domains, starting from structural mechanics, bridge engineering, structural health monitoring, wind engineering, earthquake engineering, and so on and so forth. So we have a shake table facility where we will simulate real earthquake scenarios. So you have to feel. The earthquake, because basically when you talk about a signal or something like that, you will be having a spectrum where you are talking about either dealing with low frequency or high frequency. Earthquake is basically a low frequency kind of a thing, because once it is a low frequency only, you could be able to feel it. Because when building is shaking during an earthquake, you go and touch the structure, you will feel the vibration. So you could understand that it's basically a low frequency. But if you take a high frequency signal passing over any structure or a medium, if you touch it, you may not be able to feel it. It's about high frequency. You all know that frequency is inversely proportional to wavelength, right? So basically, low frequency we can be able to identify bigger size of damage. High frequency, smaller wavelength, so we could be able to identify smaller size of the damage. So basically, that's the philosophy we will work on. So when we want to deal with smaller size of damages, if you take an aircraft structure, there even 1% tolerance is not allowed, 1% error is not allowed. So there we will work on with high frequency techniques, where a fluid structure, even minor size of damage, some size of damage to identify, we will work with low frequency kind of signals to monitor. So that's why there is something called as period wave propagation that is there in the area of the health assessment kind of a thing. So my outline of the talk will go on like this: just an artificial intelligence introduction, artificial intelligence for smart agriculture. Like what all the applications are there, then going with computer vision and deep learning models, convolutional neural network and transfer learning. Three major tasks are the models in computer vision and deep learning. In computer vision, classification, object detection and segmentation. What we have developed pertaining to our civil infrastructure has been presented. Then focusing on digital twin. What is mean by twin? You have a brother or sister similar to you. It's called a twin. What is mean by digital twin? It is about a virtual model of that. So it's basically a digital model of anything. Like you are there, a similar virtual model in your system. It's called as digital twin. But it's just a computer model, right? Then why they call it as digital twin? That means it will have a connection with virtual world as well as the physical world. That means data transfer has to be made between the physical world and the digital world. That's called digital twin. Like I have a structure, I have a similar model to it. So tomorrow I am going to predict that earthquake is going to come. So what I do is that it will predict that whether the building is going to be safe or not. So we can evacuate the people here. So that's the concept of digital twin. If we take anything, whether we want to shut down a power plant structure or not, if we have a digital twin in it, we can make a decision on it. So that will be a thing. So finally, opportunities in smart infrastructure, closing thoughts on the way forward. So what is meant by artificial intelligence? Intelligence, can you see it? Can you touch it? Can you feel it? Nothing is there. It's all behind the scenes. So that's what. But what is there? One thing which is in a physical form. We call it like an artificial intelligence. I think robot, which we give a physical body to a system, physical body to it. So basically, we can call robot as a thing which will have some physical body or something. So that's why we can tell something like an artificial intelligence. Do you recognize this? What are these pictures? First one is what picture? First one is the picture of advisor. Second one is the picture. How you identify it? How you identify it? How do you recognize it? I told the name, no. That means how you have been told that because no, it's just a picture. How you have learned it, how you have been saying it. It's about you are trying to understand some pattern. right? If a picture of a cat is being given, you are trying to understand some pattern. Okay, you are trying to interpret some pattern from the picture because everybody perception is different. Because you also say the answers Abdul Kalam, he also says the answers Abdul Kalam. But your thought process of the perception is completely different, right? You will be having your own thing. Like if he looks like that, you will name him as APJ Abdul Kalam. If you would have been certain features for him to name him as APJ Abdul Kalam. I think each individual perception is there. So you have your own pattern or future to it, to remember it in your own way for your interpretation. So basically, how human learns is that it's basically through patterns in the case of images, then by an experience. Because how the children try to learn to walk, it is like slowly it tries to walk, it fall down, then it will start to fall. So it's basically a trial and error process, and then based on the experience. Like how the children will learn that fire will heat. Once you touch it, once you got hurt, you will feel it. Okay, it all based on the senses. So everything is about it's about reasoning and then understanding and then remembering it's some relationship to it. If you touch the fire, so you keep a relationship that if I touch the fire, you will get heated. So but you are giving a relationship to it. That's what you try to call it as intelligence. So based on this cognition ability only, we develop the language, philosophy, mathematics, science, technology, economics, and so on. So basically, what is mean by artificial intelligence? Who got Nobel Prize in physics is basically who invented neural network, right? So basically, the neural network was developed so forth in I think 90s, but why it has come up into this research evolution? Because of the evolution of the computational resources. We have now good GPUs, CPUs, so that's why it has been developed. So right, so far earlier we have done only on programming. Programming means what? If you have an equation of a straight line to solve, right? I have given some points. Now I am trying to predict for a future value of say x, you are trying to predict y. That means, how do you program it? How do you program it? You give x, you give y, and then you try to give an equation. Y equal to mx plus c, or you try to give an equation to model that, and then you give for ask for any value of x, you are trying to find out y. That's basically called as rule, right? Rule. Then data is x, you are trying to predict the output y. That's called as traditional programming. But in artificial intelligence, either in machine learning or deep learning or anything, we are trying to give x and y. We are not going to tell the equation what is y equal to mx plus c. The system has to understand that y equal to mx plus c, it has to derive on its own. But it won't tell that what is its form. Unless otherwise you try to interpret it, it won't tell that. So what you have to do is that you try to give for 1, the value of y is 1, for x is equal to 2, value of y is 2, for x is equal to 3, value of y is equal to 3. So like that you have given some values. So x and y is being given, the system is trying to learn the functional mapping between the input and the output. How it does, that's what the basic. So basically here, input and output is being given. Input is data, output is answers and labels being given, and machine learning model is trying to understand the functional mapping between the input and output. Basically the pattern or rules. If you take any machine learning or deep learning techniques, it all converges starting with the equation of a basic straight line only. That's why I'm still giving an example of an equation of a straight line. So just to talk about it, artificial intelligence means a machine is trying to mimic the intelligence of the human. That's what it's about, artificial intelligence. So in that subset it's called machine learning, in that subset it's called deep learning. Now we are talking about generative AI. Machine learning means machine is trying to learn from the data sets and trying to predict. Deep means the same thing, but it is going to be further deep. You always try to learn from the basic terminology. Deep means it's trying to be deep. Generative AI, what is meant by word generation? Generation means you are creating something new. So basically generative AI is all about creating new content. That means earlier which I have talked, you have given input and output and trying to find out what is the relationship between them or what is the equation is trying to model. In case of generative AI, it is nothing like that. You have given only some huge amount of data. Nothing else, right? That's all. You're giving some huge amount of data. It is trying to predict something new. Okay, that means today it's going to rain. So I have to wear. It is going to predict the next code called raincoat. That's it. Fine. You got the point. That's the basic philosophy in which the ChatGPT is being developed. Large language models are being developed. Okay, so that's what it's called generative AI. So generative AI is about generation of new data. Either it can be a text or it can be a images or anything and so on and so forth. So large language models. Large language models. Why the new word called large language models have come into the picture is that generally, you know, when you try to do an optimization problem or anything, what you try to do is that you try to do huge number of iterations to try to minimize the error. At a point, after a point, it has reached some stage of an error. After that, it tries to remain constant or it become plateau. But in the case of large language models, because after you reach some 1 lakh iterations, whether you go for 2 lakh iterations or 3 lakh iterations or 5 lakh iterations, the error is not going to be improved much. That means it has reached a plateau or it has reached the minimum error, you are going to stop the problem. In the case of large language problem, when you are going to reach the larger stage, larger iteration, its performance is going to increase. That means that is going to drop down. That's why the word called large language model has come into the picture. You got the point? It basically starts from conventional thing. The word has become that based on its differences it has come. So foundation models basically comes under large language models. Generative adversarial neural networks, it's about creation of data. Diffusion models, it's about creating images or new data from the noisy data. So that's what I feel. So what is the basic difference between machine learning and deep learning? Machine learning is a subset of artificial intelligence. Deep learning is a subset of the machine learning. So since I am dealing with images, I mostly talk about neural networks. So here in terms of machine learning, this is called the classification. The neural network is called the functional network. Like it's like MX+C. That's a classic model. But here in machine learning, you have to do some pre-processing. That's called future extraction. That means we try to, like, you have a gearbox equipment is there. You are trying to put an accelerometer over there and you are trying to get a response over it. Okay, if we take a response of the signal, if you measure for 1 hour and at the rate of say 1000 hertz sampling frequency, that means for 1 second we are going to have 1000 samples. That means for even for 36 seconds it goes to be 36,000 samples. For 360 seconds it's going to be 3,60,000 samples. So the size of the sample is going to be very large. For a single sample itself, the length of the input is going to be some in terms of lakhs. The dimension is going to be in lakh. But in order to feed, instead of feeding that signal, why don't we take a peak of that signal, some peak points in the signal and try to give? Okay, so it may be called as a future. Or else you convert that signal into a Fourier spectrum. What does Fourier transform does? It basically transforms. It has to transform something from something to something else. Fourier transform does conversion from time domain to frequency domain. What is the advantage of converting time domain to frequency domain? We'll try to see some peaks in some frequencies. So those are the major components. So those peaks alone you try to extract and keep it as input. That's basically called as future extraction. Okay. But here there is an intelligence of an future extraction. So here future extraction scientists will come into the picture. No sir, I don't want to do anything, all those understandings I don't want to do. I just want to give the input directly, I just want the output directly. That means you just go directly. But here it's just 3 layers, but here it will be deep layers, like 10, 100, 1000 layers, it will be going to be deep. So basically, machine learning, it has the initial process of future extraction, but here it doesn't have the future extraction. You can input the raw data as it is. That's the major difference between machine learning and deep learning. So the deep work comes into, it goes into deep. So here I have taken a car. What kind of features can be used? I have given an image of the car and I am trying to solve the problem of a classification problem. I have given input image is a car. It has to tell that whether it is a car or not a car. What kind of features I can extract from it? Car has how many wheels? 4 wheels. So you can extract a feature like a 4 wheels. Okay. Like if I have 2 wheels, it's going to be a bicycle, right? So that's why it need not be a car. So I am talking about the future is like that one. Okay. So finally, now we have an input. Like input is image of some object or something like that. Output is you are going to define it. So basically that's called a classification problem. Given an image to it, you have to tell that what is in that image, whether it belongs to a car or not a car, like that, that's objective here have been shown. So basically what we have in the hand, the data that we learn. Okay, that's the data means the input and output is in the hand. This is the basics of any machine learning model or deep learning model. This is the anything you see, it follows the 4 strategies or 4 steps only. So I think it's very fundamental. You have to go through it. Then a model with parameters to predict output. Model means you are trying to assume some neural network to it. Neural network means you are trying to assume some equation to it. Let's take it. So it's like 3-layer deep, 4 neurons wide something. You are going to assume some model. That means you are going to make some model. In that model you have parameters like number of neurons, width of the neurons, depth of the neurons, and then they are called as parameters. Okay. So how we have to train? First thing is that how we have learned. It's all about, it looks like a black box. The image is being given and you are being told car. You are trying to perceive in some sense, trying to learn it is a car. Okay, that means you are being given some 1,000 images of cars and from that you are trying to extract some features. Okay, that means how you are being evaluated, you have given a new picture of a car and being tested like whether it is a car or not. Right? So that means what is that you given the system or the machine learning model or deep learning model 1,000 images of a car and tell that this belongs to the car, and you try to predict you give a new picture of an image and try to tell that whether it is a car or not. If the image given is a car and it tells a car, error is found to be 0. If you have given a car and error is and you tell that it is not a car, that means the error is going to be say infinity. That's all. Either it has to be 0 or infinity in a simple sense to speak about. So in mathematical sense it may come up in the picture. So 0 and infinity is error. So that means you have to minimize the error. So basically input and output is given. You have assumed some equation for it. Y equal to mx plus c. You assume some coefficient m and c, and then for new input of x you are trying to predict the y. So you are trying to minimize the error y minus y cap. How do you minimize the error? How do you minimize the error? How do you minimize the error? Like x is equal to 2, y equal to has to come 3, but y equal to coming is 3. So now what should I do? That means the coefficient m has to be tuned here. Y equal to mx plus c. Let us say c is 0, y equal to 2x, let's take x is equal to 1, so y has to come 2, but it has been predicted as 2.1. That means m has been become 2.1. So that means I have to change the value of m. That means change the value of the m or the parameters. So how to do that? Okay. But it's a very simple thing. Y minus y cap whole square, that you have to minimize it. Means basically that I have started with proof. You have been seeing this basically like the Newton-Raphson method. Newton-Raphson method to solving algebraic set of equations. So in that what you will do, you try to assume some solution like m is equal to 2, you assume find the value, then m equal to 2.01, m equal to 2.02, or else 1.98, 1.99, like that you will assume trial and error and you will go on. But here, so finally, the size of it is going to be, when you have a large amount of data, its size is going to be very large. So it has been addressed, the error minimization problem. Instead of going through a trial and error process, it is being addressed through a problem called optimization. Optimization means you are finding the optimal value. That means a correct value to it. So you are trying to minimize the error here through an optimization function. That means you assume some initial value of m, you are trying to update the value of m through an gradient descent algorithm or gradient descent algorithm or Adam optimization and all is there. So basically, now you assume that first you have x and y in your hand. Second, a model with parameters to predict the output means you know the equation y equal to mx plus c. M and c are the parameters you have in your hand to know. Third one is loss function. Y minus y cap is the loss function. Fourth one is that you are trying to update the ML. So this is the 4 major steps in the any neural network or any machine learning model or any deep learning model as such in overall. So now comes into smart agriculture. How this neural network or machine learning or deep learning is going to help or influence in the smart agriculture you take. First one, right now how you are doing, we are using tractors to plow the fields. Okay, but plow the fields. But to do it, to monitor the level whether we have, because it may be a irregular terrain. In order to do it, if you put it with a cameras, you can find out the terrains, whether the work has been done and what path it has been done. So that's where there comes like hardware components, like tractors that should be also customized and integrable with cameras or something like that, or else even fitted with other sensors that it can be fitted with some moisture sensors or humidity sensors to measure the humidity of the soil simultaneously. That can be sensors and actuators. Means you are trying to collect the images using drones. It may be a sensor, or else I think you may be reading about fiber optics. I think you have a fiber optic cable which may be running along with the pipeline. So that will also be used as a sensing device to monitor something. So they also comes into solution like sensors and actuators. That is also one area it has to come into picture. But again like now everybody is talking about driverless cars. Like Tesla is talking about driverless cars. That means the person does not have the driver. So I should have a very smart system. That means I have a tractor to plow the field. That means it has to go automatically plow the field. That means First you should have a path. Okay, I should go straight line, then I should take a reverse, then I should come back and do it. So that means it have an automation of planning. That means it should have a GPS coordinate, everything comes into play. That's why question and telematics it has come into the picture. Then communication technologies means now the data is there. The data has to be transmitted. Okay, or else you want to develop an app that gives a warning to some person or a farmer. That means it comes into cloud computing or edge computing. Everything will comes into the picture. Software system means because if you given a solution to a farmer, he should be simple to use it. So that means a complete holistic system will come into the picture. Data-driven solutions is like what we are developing or what we are working on, like deep learning models or machine learning models or computation models, whatever we name it, that comes under the category of data-driven solutions. So majorly I will focus on data-driven solutions. So if you take computer vision from images, what and all we will do is like crop monitoring and health assessment. That means whether the crop has been grown into it or not, whether leaves have come, whether first initial stage of seed sowing, whether the plant has grown, whether it has given the fruit or not. So we are trying to monitor whether it has attacked by any disease, so that we can monitor from the images. Then crop yield estimation forecasting. How you estimate the crop yield? That means we are taking only the images, but during sunlight, its shadows, its canopy will be falling on the floor, right? So based on that area estimation, we could try to estimate that how much it has absorbed its nutrients from the sunlight. So we could able to understand that how much it will yield. So crop yield monitoring they can use. Precision agriculture means when you want to do, basically we follow in our fields drip irrigation, right? We have a pipe fitted to the area which has been given a circle or oval set, and then we try to water it. So precision farming means exactly what amount of water is needed, it has to be given in that way, it can be contributed. Then livestock monitoring means when you are trying to do the livestock like sheep or goat, it may go into various places. So where it has gone, try to monitor it. For that comes into picture livestock management, automation farming equipment like drones or tractors, everything has come into the picture. So that I have talked about it. So this is the same thing comes into the picture. So comes into vision. I think vision is it's like an intelligence itself. So that's what here I am trying to mean that. So more human brain devoted to vision, anything else, because generally we study books, right? If you read to understand a paragraph, because basically we study history in our schools or something like that, teacher will explain you some historical stories or something like that. In order to try to understand, you may not try to understand, but you go and watch a movie, you will remember the story, right? So basically, we have good adaptation to the human vision, and that's what here I mean that more human brain devoted to vision than anything else. That's what I mean we here. So basically, you are using mobile phones, right? It has some megapixel, right? 30 megapixel or 20 megapixel or 10 megapixel. So right. So what is the pixel? Pixel is the smallest size of the image. What is mean by the 30 megapixel? 30 megapixel or 10 megapixel? What is mean by mega? What is mean by mega? 10 over 6, right? So that means I am using a camera of 1 megapixel. That means it has 10 power 6 pixels. That means it can be 1000 by 1000 resolution of the image you will take. You got the point? What I am trying to say? So megapixel means if you have a 1 megapixel camera, you take the image, go to the properties, you will see that it is of resolution say 1000 by 1000. Okay, if it is like something else, the resolution will vary according to its camera size. Okay, you got the point? So that's what. So basically, image is being, even though we are capturing an object of a 3D, we are getting into a 2D image. Okay, it's basically you have an x-axis and y-axis into the picture. So what you are going to infer, you are going to make some inferences and meaning from it. So basically, that's what I mean, whether it's a bicycle or a person or something like that. Then sometimes, because since I have background of civil engineering, I use images to monitor. Like I have the DST, I know the distance. If I have a crack, I have to monitor the crack length. So to quantify the crack length, it is also used to measure geometric inferences. Semantic inferences means what are objects are there. Then, like in computer vision means driverless cars are there, right? Driverless cars are there. That means it has a computer vision technology. That means what is that inference is about action. That means an abstract is going from how to put a brake, right? So that's what inference is about making an action. And in geometric inferences, semantic inferences about action are being told. So how computers see only in terms of the numbers, right? So this is a bridge structure. How computers see is basically a numbers. So basically, this image is being seen in the form of a matrix, right? That's what I just want to tell. So basically, from this matrix only, we are trying to derive some information for it to work on. Okay. So this is one of the important points which you have to remember. I think my talk will be mainly covering this part only, 3 parts only. So there are basically 3 terminologies in computer vision. One is called as classification, another one is called as object detection, another one is called as segmentation. These 3 terminologies are there. Whether you read any YouTube channels, whether you take any textbooks, whether you do any project in computer vision, you will only go through these 3 seminal tasks. One is called classification, another one is called as object detection, another one is called as segmentation. This is what I call classification. Means you give an image, what are whether it is a car, whether it is not a car, whether it is a cat or not a cat. Then object detection means you have identified a particular object. Where is that object in that image? Okay, that's called as object detection. That also been classified as classification and localization. Classification, localization, object detection are same, but here it has been shown a single object. Here it has been shown a multiple object. Segmentation means pixel wise you have to quantify. In object detection, here there is a cat, but I am trying to put a boundary or a region where the track is there. It may be a small boundary or it may be a larger boundary. So it all depends upon your efficiency of the model. So that's what it's about object detection. Segmentation means exactly at what pixel it is there. So it's called segmentation. So classification is you have to remember that classification word comes means it has to be remembered at the global level. Okay, classification means at the global level. Object detection means at the region level. That means in the global part of the image, in which region of the global part that object is there. So it can be called as region level. Then segmentation means you are trying to map the object at the pixel level. So these basic differences you should know. So basically classification is about you are given an image, you are trying to tell what object is there. Then object detection is about you are trying to detect the object and as well as tell that in what region that object is there. Third one is that segmentation. Pixel wise you have to quantify that where the object is there. So here you are trying to do and perform only a classification. But in case of an object detection, you are trying to identify this bounding box. That should be a coordinate. Like this is 1000 by 1000. So this should be, let's say this is 0, that is 1000, that is 0, that is 1000. So it may be 100, this may be 500, so this may be say 600. So this is like 100, 0, 500, 0, like 100, 600, 500, 600, something like that. These 4 coordinates also you are trying to find. So basically, that's what you understand. So basically, here it's only a classification problem. Here it's a classification and regression problem in the case of an object detection. So let's come into my area of expertise. This is service learning. So first thing is that we have a crack or any kind of a defect. So image classification, we try to tell that whether there is a crack or recoil exposure or something like that. So next, in which region it is there. Next one is that at what pixel level it is there. So basically, you have an image. We try to use drones. We collect the images and we automate the process and try to tell that in the image where there is a crack, then at which location the crack is there, and then exactly quantifying it pixel wise. Because quantifying pixel wise only they use the geometrical information about it, like length, maximum width, direction, that means orientation of the crack, so that how far it will propagate and it will fail. So that is the basic classification. So majorly I have been working in this kind of an application and giving an equivalent application in case of smart agriculture. So here you have to understand that it's basically whatever we are trying to deal with it is completely supervised learning. That means we have given an input and output and it is trying to learn its model, and then for any data it is trying to predict it. So whichever I am going to discuss is completely audible supervised learning. That's what I want to tell. So 3 major tasks in that. What I am going to tell is that what is that output you are going to get. Input is going to be an image, right? What is the output you are going to get? Because I think whenever you take up a project or anything in your bachelor's or master's or anywhere, I think basic understanding is very much essential, which will take a huge amount of time to work on. So that's why I have given this simple explanation. So data is an image. In that there are 4 classes. Let's take what is the probability of each class. So this is the probability of the higher class, that maybe you can take that as an object. You take an image, it tries to tell that in the pixel like 105, 221, 187, 107 there is a dog, 156, 501, 124, 501. It can be like 4 coordinates of the box, or else center coordinate of the box and the width of the height of the box, maybe these things. That is in the case of an object detection. In the case of a segmentation, it is at the pixel level. Okay, but here you tell that input is an image, right? What is the size of the image? If you take a 1 megapixel image, 1000 by 1000. That means you are giving a 2D input to it. But here the output is like, if I have a 5 class, it will be a vector of size 5 by 1. So this basic understanding is to be needed for classification problem. So You haven't given an input of size 1000 by 1000, you are getting an output of size 5 by 1. So, for a high class problem. In case of object detection, you are giving an input of 1000 by 1000, you are getting 5 by 1 class as well as its corresponding bounding box coordinates you are getting. Here, you are giving a 1000 by 1000 input image, you are getting 1000 by 1000 input image itself. That means size of the input and size of the output are same in the case of segmentation. That you have to absolutely remember. People who are interested in it, I think they have to note down this point very clearly. So basically here what is happening in first two cases, you are trying to reduce the size. But in the last case, what they are trying to do? They are trying to keep up the same size. Basically future extraction. Basically in machine learning, what I have told, in machine learning it's all about first step is future extraction, then only it goes to the neural network, right? That means you are reducing the size. You are reducing the size of 1000 by 1000 into it has 4 wheels. Like it has 4 wheels, then it may have 4 windows, doors, something like that. You have given it future. That means 1000 by 1000 you reduce into some 5 features like that you have reduced. But machine learning, deep learning, it has to do the process automatically in it. That means basically initial layers of the neural network will focus on reducing the size. Okay, so basically initial layers of the neural network focus on reducing the size because they have to extract some feature means they have to reduce its size. So in segmentation, most of the algorithms in case of segmentation will follow the philosophy of encoder and decoder architecture. Encoder tries to reduce the size of the input whichever you are given, then it tries to upsample the image. Like from 1000 by 1000 it is reduced to 10 by 10 or 10 by 1, then from 10 by 10 or 10 by 1 it is again getting back to 1000 by 1000. So encoder is about downsampling, decoder is about upsampling. So in case of segmentation, input and output size are same. That you have to remember to. In case of an object detection, input size and output size are different. In case of classification, input size and output size are different. So this basic understanding will help you to develop any algorithm or anything into very fundamentals of it. So I just given the different kind of algorithms which has been developed so far available in that. In case of classification, AlexNet, BGGNet, SNet, DenseNet, efficient different transformers, full transformer, convolution X, like that is there. Object detection, regional convolution neural network, fast processing, YOLO, direction transformer, so on and so forth. So these are the various algorithms in different categories of like classification, object detection, segmentation, generation, tree and video. So I think I will skip neural network for the time being. Okay. So I will just tell you like what we are trying to do just to give a basic idea. Basically, what is the difference between neural network, a convolutional neural network is there. Convolutional neural network, people are terming called as convolutional neural network. People are calling something called as recurrent neural network. What are those three differences and what is that? You can call recurrent neural network or convolutional neural network is the subset of the artificial neural network itself. Okay, in convolutional neural network, we perform the operation of convolution. Right? In case of recurrent neural network, what is mean by recurrent? You have a fixed deposit, you have a recurrent deposit, right? What is mean by recurrent deposit? I am not taking anything from the subject, right? I am asking like what is mean by recurrent deposit? It's like you will be having a follow up on the previous instances also. Fixed means on the fixed amount it is there. You got an interest, that interest is added to the fixed amount, the deposit, and then based on that interest has come. Like you have deposited some 1000 rupees, you are getting 50 rupees interest, 1050 you will get. In the next year also, you are keeping that 50 interest you have taken up and 1000 only comes up, again interest for next year follows only 50. But in the case of recurring deposit, you deposit 1000, the next year it becomes 1050. Because of the 50 interest, the original principal will become 1050 based on the interest to be calculated. So it depends on the past history. So recurrent neural network, if you take, it is good for speech signals. Speech signals are anything dealing with the signals. Convolutional neural network, if you take, it is good for dealing with the images. That's what I will try to say. So basically, these are two operations called as convolution and pooling. Convolution, it tries to multiply with a kernel, and then it tries to do it. So kernel means what it tries to do is that you have an image. Okay, I am multiplying by some kernel called as blue kernel. What it tries to do is that it uses an image something like this. If I take something like an sharpened kernel, it uses that image like that. That means it's trying to sharpen the edges. If you take an vertical extended kernel, it will use the So basically, even though you see it as like a matrix, original image is how the image is being changed. So basically, each neural network in the convolutional cooling process, what is happening, you could able to understand. So that's what it's all about. So then cooling means you are trying to reduce its size from larger size to a reduced size. So cooling basically reduces size, but actually it tries to focus on the different parts of the image. This is the original image. What cooling has done is that this has it has done it. So that's what it has done. I don't want to get into this. Okay, let's come into transfer learning. Like transfer learning in the sense. Now I have talked about convolutional neural network. Convolutional neural network means you have an input and output in hand, and you are trying to, for a given input, you are trying to predict the output. That's said to be an convolutional neural network. But let's take you have an input, certain inputs for a new defect. Like a person is tall or short. For that, you have to collect 1,000 images of a person coming from the tall, and then 1,000 images of a person belonging to a short, and then you have to train it. Okay, it takes huge amount of training. That means you have to collect a huge amount of data. That means when you develop a driverless car, let us assume that the driverless car is being trained on a city like Chennai. Okay, again for Coimbatore, whether I have to retrain it, is it possible? Okay, I made driverless car, I brought it to this city, I have trained on this city, like okay, this is the traffic condition of this Indian scenario, you try to learn it, and then I am trying to fine tune it and I am trying to develop it. Whether I should again train it on a city like Coimbatore, or whether a city like Madurai, so on and so forth, no. That means if I try to know how to ride a bicycle, it is easy for me to ride a scooter or a two-wheeler, right? Two-wheeler, right? If I know something basics of two-wheeler, it is easy for me to buy a drive a car. If I know to drive a car, it is easy for me to drive a truck or something. That means a knowledge from one model has to be transferred to a other model. So that's basically called as transfer learning or something. That means what they have done is that researchers have worked on some 1 lakh million classes of data, and they have trained it and developed an architecture already on it. So you use that knowledge and then try to only freeze or update the last layers and try to make the prediction. It's called as transfer learning, or otherwise it's called as pre-trained model network. So that's the basic philosophy of the transfer learning. So either you can develop your own convolutional neural network architecture, or else use the existing architecture and its existing weights and biases, and then only update the last layers, or transfer the knowledge of that model to yourself and then use it. So that's what. So basically for that purpose, various models have been developed. So the brief history has been given here. So classification problem, as I told. Now in the case of an agriculture problem, plant disease detection, like classifying healthier disease plants, we could able to divide image. So you have a drone or something like that will be flying over. So by seeing the image in case of bell pepper, if it is having any issues, like this is called as active part, it will be detected automatically by the classification algorithm. Whether the leaf is green, whether the plant is green, disease, it has a disease or not, it tries to sell. This is for the different category of the graph that has been shown. For the soil type, you know that for dark soil, wheat is going to be grown better. For red soil, groundnut, potato, and cotton is there. So in order to have a huge village, what to craft, what to show, what type of seeds to grow, you can able to get an imagery, and then you can do a soil classification, and then you can tell what type of seed can be grown. Similarly, weed and pest classification can be done. So then quality of the food, quality of the foods like apple, whether it is good quality or bad quality, how what it is, whether it is ripened or not ripened, whether it has grown or not to cut the fruits. So this can be considered as a classification problem. So this is an work has been done on civil engineering aspect. This is on a structure with about 6 different types of cracks. Like there is no crack, then there is some dense kind of thing is there, then rebar has been exposed. Another one is like something like white patches are there, another one is crack, another one is any new defect is there. So this kind of a classification is being developed using an already existing pre-trained model called as inception network. So I try to find 2 different layers and try to find out its accuracy. It's found to be better. So that's the thing. So this is on the same thing has been applied for a fruit classification, whether it is unripe or underripe, ripe or overripe. So this is that different category of classification. So in that classification, whether it has classified or not. So how do you evaluate the accuracy of the model? It's called as confusion matrix. why it is called as confusion matrix? Why the word called confusion is there? Like I am trying to actually I have given 20 samples in each category. In testing, I have trained a model, given some 1 lakh images of unripe, underripe, ripe, and overripe category of images, and I trained the model. Now I have given each set of images 20 images in each category, and trying to ask the model to predict. It has predicted the model and shown the output. But why it is called as confusion matrix? Why the word called confusion matrix? That means it is being confused between different categories. If you take it has been absolutely identified, that means it should be purely diagonal. That means it should be 20, 20, 20, 20, 20. But what happened here is that this 17 is in this 20 has been split up into 17 and 3. This 20 has been split up into 17 and 3. That means 3 fruits it is confused between the category of ripe and overripe. So that's why the word is called confusion matrix. That means it is being confused between the different categories. That's why it's called as confusion matrix. So basically it comes as a pure diagonal matrix. So then only your system is very much perfect. You give 20 samples, each category should come 20, 20, all should be 0. So then we could understand that it is majorly confused between ripe and overripe categories. So we have to address this problem. We have to modify the architecture and do the process accordingly. Which layer we should intervene on operating, it will give an indication. That is also an information or indication to resolve the issue. Getting into object direction. Yeah. Fine. First one is classification algorithm. Another one is object direction algorithm. Object direction algorithm. I have detected now ripe fruits in it. Okay. Exactly. Now I want to not when I am trying to pluck with a robo. Let's assume that I am trying to pluck the fruit with a robo. I want to avoid the unripe fruits. That means if it like assumes if it is in a clusters, I want to remove the unripe fruit. That means I should know where it is in that cluster, where that unripe fruit is there. Then only I can see. So that category you can perform object direction. In case of sheep or goat monitoring, how many goats are there to monitor it? We can use and where it is there. How many numbers are there? We could use it for this object direction monitoring. Then where is pest? Whether the disease has been affected, whether pest is there, that for that we can use. So, but what is the major challenge is like I have trained a model, but why still research is going on in any area is that we will always have some challenges in reality because you have collect some good amount of images, like 1000 images of an apple and shooting it is very well. But the thing is that here an apple is being typed between 3 leaves. So if you give an image, it may detect it as a leaf, not as an apple. So you may have this kind of a confusion. Then you may take a picture in the morning, you may take a picture in the evening. So different lighting conditions will come into the picture. Okay, then again, see there may be 2 different trees will be there, different fruits will be there, their overlaps will be there, so that you may not be able to think. Then in a cluster, some fruits may be hidden, that cannot be there. So there is always some kind of a challenging, interesting things will be there in that to work on to identify. So in that, majorly people have been using like reduction transformer and you look only once algorithm. YOLO, I think YOLO means you look only once. It has been in a great state of thing now. So basically, it is trying to divide the image into grids, and each grid is trying to tell that whether it has an object or not, and then tries to find its boundary. That's what it tries to tell. So what is the interesting thing I have done is that people try to generally use like rectangular bounding boxes, right? But in case of civil engineering applications, if you take a crack need not to be in a straight line, right? It may be in an inclined portion. So instead of using a horizontal box, why don't I use an inclined box such that accuracy will be more faster in prediction, so that I can easily predict the length. Because inclined length is the true length, I can predict the length inclined way. So that's why I've been working on with oriented bounding boxes. So it's called oriented Euler algorithm. So some results on oriented Euler algorithm on different types of cracks has been presented. So now this is about pesticide production. This is a tractor going in a field fitted with 5 different cameras. It is trying to locate in which region the weed is there, and then it tries to remove it. So it is trying to, when it tries to scan it in each region, it tries to localize the region and then tries to predict it. So this is the application of the object direction model in the field. So this is some results on it. on implementation of Dodo algorithm on different models. So going into segmentation, it is on exactly and quantifying up to which pixel level it is there. This is the results on some track images. So this is segmentation in agriculture perspective. If you take where this pixel level mapping is required, because I don't think like in agriculture sector segmentation has a major role as such. Even though because you localize the region where the fruit is there, it is easy to pluck the fruit, or else you localize the region where to water the seed, that is more than enough. You don't need pixel level of quantification to do for agriculture purpose. But there are some applications. One is cotton impurity. Because you have cotton, there will be some impurities, something will be there, fine particles may be there. In order to detect it, you have to detect it at the pixel level. So for that, I think segmentation algorithm will capture the picture. You have to understand that here input and output size is same. Input and output size is same. So that's the major thing. Then another one application is that this is in the weed. In a group of plants, if there is any objective weed is that in order to identify it at a pixel level. When you do a satellite imagery or hyperspectral imagery, you can do this problem and try to do it. This is the basic objective of it. Okay, so far I have been talking about conventional models which is already existingly available. I have used those models and really implemented for this problem. But right, so these models or anything is available only for the predefined data set which is already there. I have used transfer learning concepts and trying to develop it. But in case of civil engineering, I have to acquire this kind of new data. That means data generation itself is a task, and then input and output I have to do. That means I have to label the pixel-wise labeling I have to do. But I have to acquire the images with pixel level labeling itself. It takes like some years of work to do it. So what I try to do is that instead of going directly into segmentation, what I try to do is that I try to do only supervised object detection, and then segmentation is done in an unsupervised way. So this is the philosophy I try to work on. First I try to identify the region where the horse is there. Then I use it as the input of the box as well as the original image as the input to the unsupervised model called as segment editing model. And then I try to predict the mask in it. So this has been a major advantage because for me, crack will be there, scarring will be there, different kinds of defects in case of smooth structure will be there. So basically here I reduce the task of output labeling. That's what the major innovation is being done here. It's called as zero-shot segmentation. Zero-shot segmentation means there is no training involved. Zero samples in the case of training for segmentation, or that's what is called as zero-shot segmentation. So I combine technique of object detection trying to predict the bounding of, it will act as a prompt to the unsupervised segmentation algorithm called segment editing model. So basically integrate Dodo level and SAM and try to compare the results with the existing algorithm because it has a major advantage in my area of work of civil engineering. So this is that result. So this is taken on a tile image, this is on a wall image, this is on a pavement. So some results have been presented. Then I think I will go on with the video. Okay. Here I am talking about something on a full scale model which I have done at power plant structures at Vallur, at metro power plant structures and then 2 power plant structures where we have used drones to collect the images as well as we have used lidars also to collect the 3D point cloud data and then merge it and then try to use the 3D cloud data. Because when we try to inspect a structure, what happens is that you collect the images because generally we go visually see, okay, I see here and try to tell that, okay, this is the crack. But when we work with these algorithms, what will happen is that we have to categorize it or we have some manual operations to do it. Like physical exercises are involved. Like we have to go into a structure. This is the first floor of the building. This is the second floor of the building. We have to create a subfolder name. These images are taken from first floor. These images are taken from second floor. These images are taken from third floor. These images are taken from fourth floor. Like that I have to take. But again, the client will ask us that if there is a crack, you have to tell them which location it is, whether it is the third floor or whether it is the fourth floor. He has to tell. So what they need is that they need a 3D model. In that you have to tell that exactly the thing is that. So I don't have to tell that. I don't have to use some land its processing has to along to it and then try to tell it. So that's the thing. This is from our so what we are finally looking at it. This is like a grid structure. We have gone to the grid structure. We have taken different directions of photo, geotag, RGB images we have collected, and then reconstructed the entire structure. It's not just a video. It's actually only taken from the images. This 3D model of the structure has been constructed using the principle called photogrammetry. There are open source tools as well like X4D from Bentley IP capture it is there. So yeah, so now what will happen is that just click on this nice arm. Now you could able to see that this is a 3D model. In that one red color has come. Just go back, Yeah. Okay, just click on nice. Fine, you could see that. Okay, you could see that now in that region, this region there is a rebar exposure. This algorithm has been embedded into the 3D model software, and if you try to identify it, this is the region of the rebar exposure. This is a high-rise water structure at Metal Power Plant. This is about 180 meter height. We have taken photos at different directions. We have made a path, like a circular path. We have automated the path planning of the drone, and then we have collected the data, and then we have reconstructed the 3D model of it. So now you could see this is being processed in a software and it has been screenshotted and converted into a video. This is not just a video. So I think now you can see each individual description of the entire structure. So finally, if there is any crack or any opening is there, it will be identified by the algorithm and it will be displayed. This is the May2. The chimney is about 2 centimeter height. This is about 2 centimeter height. We couldn't able to, since there was a smoke outside coming in it, we couldn't able to take the full amount of information at the power plant, and we have also made a path plan in a larger way. So that's why we couldn't able to reconstruct it fully, and we are working on it further. So then our algorithm will be, if there is a crack or anything is there in the structure, it will be known to it. So basically, this is the idea. So basically, I was talking about digital twin to have a virtual model of the structure. This will give you about a geometrical information and then actual shape of the structure. So now you can integrate into any model structure, and then you can do analysis also. So one chimney was about 250 meters, another one is about 2 centimeter in height. We have flied it around the 240 meter only. We could fly our drone. So that's what the drone has been fitted with radar camera as well as RGB geotag video. Because when you use a conventional DJI Mavic drone, we could not have the information of the GPS. Because unless you have the information of the GPS, you cannot be able to reconstruct the images entirely. Because you take it with a conventional phone and a camera. Because you have taken a camera with stand or something, you reconstruct it using your phone. You cannot do it unless you have the geotag information of it. You cannot be able to reconstruct it. So this was being done with it. Another one major challenge we could see is that flying of drones, especially in coastal zones in North China, you could see a huge wind flying at it. Our drone will not be able to resist the wind condition. So there are other hardware challenges in it. So we could try to fly the drone at morning 6 to 8 a.m., evening 4:30 to 5:30 p.m. only. We could try to fly, and we didn't use like a heavy size drone. We used like a small size, micro size drone like Avita. So various challenges we have encountered. So that are the few cases that I say last thing. Yeah. Okay. So basically, images also, there are different kinds of images you will acquire. Starting from RGB, infrared, hyperspectral images. All three images you can acquire. Apart from that, if you have other interests, you can also have natural images as well as you want to have other images. So you have to collect different images. So then you're getting into a artificial intelligence model. It tries to do classification, object directed segmentation, and then it tries to give the information which you want, like what is the growth status of the plant, disease and insect pests, production forecast related to the income of the farmers, like RAPI. So if we will know what will be the profit we will get. So then quality analysis and then other matters, because we are continuously monitoring it. If you want to improve it also, we can be able to improve it. Then in future, tomorrow whether the rain is going to come or not, so taking it up on predictive analytics. We'll just close on with that. So basically, just working on only images won't help, because we cannot tell that because if you try to take a city like Chennai, only we are focusing on a Malayalam area, we have to pinpoint the location particularly, means we should have a complete information. That means we should have a 3D mapping of the information. So that should happen. Then apart from that, we should have a real-time analysis. It should not be like we send it to a server and then it takes time to analyze it and then tell it. Because now with the evolution of the immersive technologies, it should be real time. Because when we try to acquire the images, in order to localize the region of the pest or localize the region of the fruit, the camera should be like our algorithm has to detect that this is the region of the right fruit. So that means the camera has to zoom in that region. So that means real time prediction has to come. That means that category, this is going to be a right fruit. So the camera has to zoom. So the real time monitoring has to come into picture. Then it should be in a distributed sense. That's why when by federated learning, then multi-model data. Multi-model data means combining visual images, RGB images, hyperspectral images, even combining text as well as images, speech as well as images. So multi-model data. Because whatever I have now talked about images, it tries to give information about surface damages in case of fluid structure. But anything beneath the slab, because slab is about 100 mm thing. If there is a crack between the thing, that means infrared camera, if you use it, will get the wavelength difference. So you will get some more information to a certain depth. So their infrared images getting into play. Then you are trying to monitor whether driving a car, when a person is trying to drive the car, whether the person has been sleeping or not. We have to give a wake up alarm or something like that. In that, I don't think that mostly that happens during night time. So that means you cannot have a light. So you cannot put a light over the person and then trying to acquire the photo over it. So in that, you should have a thermal vision camera to it so that to capture the temperature. So multimodal data has to come into picture. Then vision language models, that means integration of both text and images has to happen into picture. Then synergy of computer vision and generative AI, because complex situations, like any new thing has to be created, has to be synthetically generated, and the impact has to be evolved, and then solutions has to be addressed in that way. Because now we are trying to getting into moon or Mars, whether the person can survive or not. What I mean by the synergy of CV and generative AI means we have to understand the environment and create a synthetic generative environment. That means generative AI means creation. So we have to create a synthetic environment which is going to be in the Mars, and then people will try to learn that how to live in that environment. So we can go to Mars and live. That's the concept I will cover. Then ethical AI or responsible AI comes into the picture. We have to create about deepfake technologies. Then now whether a video is being created or image is being created, whether it is realistic or whether it is created by AI, it's not known. So there should be some ethical guidance and we should be responsible. I think people whoever is wrong will always do the wrong. So but still some ethical guidance has to be created and policy making has to be done. Thank you. Any more questions? Any fundamental questions? Any general questions also?
Any queries, please?
Good morning, sir. I'm Mohammed Divya, final year AC student. So you marked geotag and shared for your model, right?
Yeah.
So what is the protocol you use?
It's one is called surveillance camera. In practically you see people will call it as surveillance camera. Another one is called as mapping camera. So when you use a surveillance camera, you don't have the geotag information. In case of mapping camera, you have a geotag information. That means basically when you try to take a structured photo with the drone, you are not getting the position of the structure. Tell the position of the drone. That means, say at a height of 20 meters, I am trying to cover the region from 0 meter to 30 meters. So I mean that this image region has been taken from 0 meters.
Yeah, so you are using geotag, right?
Geotag,
So
I am using mapping camera. Yes.
So you'll be transferring the data to the ground station.
This is being, the 3D reconstruction is being done using the process is called photogrammetry. There is a software like Pix4D, which is like open source. Pix4D or IQ capture. In that model, first we have to upload all the set of photos. You don't have to worry that once you have been collected the images using a mapping camera, you don't have to worry. There are two steps in that. You have to collect the photo, then it has to reconstruct it, and then you have to reconstruct it, then you have to region localization you have to do. Because now I have shown a major power plant where I am not localized on region. I have taken a larger area. Then if you want to localize it, you can localize the region and then render the output and then take it. In that you have an option to integrate your Python program in ONX format. You have developed Python program of anything to convert into an ONX format. ONX format, it can be integrated into that. So this AI algorithm will be acting on images and trying to map the damage or whatever your problem of interest in the 3D model.
So the software itself will convert everything, right, sir?
So once the images is being done, 3D model will be done by the software, but it is integrated with our algorithms like AI, machine learning, or different whichever develop. Our developed our existing models, so using it, we have to integrate it.
One more question, sir. This project is a team or
I have one project associated with this thing. She is basically from EC background. She is basically from EC background. That's it. This project is funded by NTPC. Next to thermal power plant project, so we are doing it for power plant.
What type of project you are doing in CSIR?
Basically, ours is Structural Engineering Research Center. We work on various areas like on earthquakes and then for wind resistant design, earthquake-based automation, robotics, 3D printing. 3D printing technology we are working on with that. Apart from that, we have called as Madras Complex, CSIR Madras Complex, where we have zonal labs of different laboratories. Central Electronic Research Institute, CE is there, apart from that CSIR is there. So where they are working on distributed fiber optic sensing. You have heard about the FPGs, where you have a grating only in a fiber in a certain region. What they try to do is that the entire cable itself will be acting like a sensor. It's called as distributed fiber optic sensing. It's just an optical cable. They will try to send a high frequency pulse in one way, light wave, and then they will reflect it and get back. They will try to find out any leakages in the pipelines or else any acoustic event, like in a railway track during the elephant crossing, it can be identified. The fiber optic sensor can be placed along the rail track, which can be used to monitor the rail track. Along with that, any movement of elephant or even the human movement, anything can be identified. So basically, research is all about interdisciplinary. If you take this application in terms of earthquake point of view, you can look like when an earthquake has happened, immediately you have to tell that whether this building people can occupy or not, whether this building has to be closed or not. That means what you can do is that you send a drone, collect the images, automatically process it, whether it is safe or not, you can try to tell an image. So it can be looked in perspective of like post disaster damage assessment also. It can be used in kind of different applications. The thing whichever you want to do. The principles will be core common, but only the area of application will be different. We invite project students from all engineering backgrounds. We have some fellowships where we invite people from electronics background, mechanical background, everywhere. We select about some 25 students also every year. We invite them and coordinate them in the projects.
Good morning, sir. I am Yogesh Reddy from final year EC department. So I have a doubt on how does a digital twin differ from traditional form management system?
Traditional form?
Management system.
Traditional form management system. You have to understand that management. The word understand that it's about managing it. Digital twin means it's like exactly what you does. The twin has to does that exactly, right? Exactly twin means whatever you are doing, it has to done. Does it? I am creating some. That means how you react everything. It has to be replicated. That means you should have a connection between the you and as well as the digital model. The connection should be there. The data transfer should be happening. That means I am trying to hit you. You are trying to move back. That means I am trying to hit you. Means there also the digital model also it should move. Okay. So apart from that, like how you respond, how you react, everything is known. So any new kind of prediction can be made. Like prediction means like you have been given the set of question papers and you have given the exam and you have got 90 marks, 85 marks, 80 marks. Now, if you give a new set of question paper, how much marks you get? Okay, that cannot be done by a management system, right? That can give you a digital twin that will tell you that how much marks you will get in a new set of question paper framed for you. Got it? So it can also undergo predictive things. It can predict us. That's what management is about. Management means it's about maintaining the records as well as smooth flow of the information. We can say that here it goes that it replicates you as such, like you as such with the connection. Without connection, I don't want to do. And anything is that it has to be continuously updated. Like some additionally now you have put on weight. That means it has to be replicated in that model. Okay, you have developed a management system. You may not be able to alter it because they have initially fixed that your weight, say some 60 kg like that, you have fixed it. You are not going to update it in the case of a management system unless some user has to interfere. But in the case of digital twin, it is automatically updated because they have a continuous data flow or transfer between digital twin and as well as that's what I see. The basic difference.
And what are the key components of digital twin in smart agriculture?
Key components. First key components in any digital twin is that first we should have a similar replica model. First thing is that creating a model. Whether you are having a reduced order model or a full stage model. That means whether you are going to have a tree completely as it is, like or else you are just try to tell that like have a tree leaf and something like that. Just to know that whether it is a tree, it is more than enough, or you should know that how many branches are there, how much information you are going to get. So first step is that modeling or capturing of the data at which level you are trying to get it. So then what kind of sensors you are going to put, what kind of information you are going to get. Because when you take something, you are not going to get some fulfilled information, right? When I am trying to get some data from you, in order to monitor BP from you, I am not going to put multiple sensors on your body. Like I am not going to put sensors on head, leg, as well as hands. Everywhere I am not going to put the sensors. I am going to put sensors only on your hand. Okay, so what kind of information you want? Depending upon that, you are going to put that kind of information on the physical structure. That's the part. Then sensor components will come into picture. Sensor component, because first you have to collect the data to transfer the information between them. So then communication technology to transfer the data. How you are going to transfer the data? Whether it's through cloud computing or through edge computing, or what is the means of communication technology, it comes into the picture. Third one, this model, this data has to be expanded into a full-scale expansion. Because now I have collected your data from something like I have collected your weight as well as your height. So that means it has to tell your future outcomes, like your body mass index is this much, so your fat is this much, your cholesterol is this much. So it has to do the process. So those techniques which are going to be integrated, which are the outcomes it is going to predict. So those algorithms or the systems it has to be coming into the picture. So first one is modeling components, next one is sensors, another one is communication technologies for transfer of information, then other algorithms or systems to give more information or interpretation of this data, and then if I collect only one data, but I have to give a complete information of the structure. So if a plant is being cut only at a branch level, that means the plant will not destroy, it will go on. If it has been cut at base level, that means it's going to fall soon. So it's local influence of the local influence on the overall impact of the system. So that it has to analyze. So that mechanism has to be there. So after that, continuous. This is what the components are based on.
Okay, sir. Thank you, sir.
Thank you, Pravin sir, for your wonderful session. I request our to honor the resource person with a certificate of appreciation. Thank you, ma'am. I welcome Dr. Ganesh Kekare, Associate Professor, School of Computer Science and Engineering from PIT Vellore to deliver this lecture.